Hi guys, welcome back to In Case of Econ Struggles. Welcome to another Arrow Debreu Equilibrium struggle. This is part 7 where I'm going to talk about how if people are perfectly consumption smoothing, you can show that they consume a constant share of the total endowment. So again, we're talking about an Arrow Debreu Equilibrium. So here's our setup with Bill and Dave. And notice that the difference here is that Bill has an alternating endowment. So he gets 2 in even periods and 0 coconuts in odd periods. And Dave is going to get 1 coconut in each period. So notice that the total endowment, or big E, which I'm going to define as ETB plus ETD, that total endowment is alternating between 3 in even periods, and it is going to be 1 in odd periods. And again, we're trying to show that both Bill and Dave are consuming a constant share of that total endowment, whether or not total endowment is 3 or 1. So just like normal, we're going to set up our maximization condition for each person. And we've shown several times that with this utility function, we are going to get to the point where we show that both people are consumption smoothing because of their Euler equation. And so we are also going to get that prices are BT. So notice that from here, from this Euler equation, where we're just saying that the marginal utility ratio between Bill and Dave is the same, we can write that CIT is equal to CJT over CJ0 times CI0. So just to put that back in terms of Bill or Dave, we can say that Dave's consumption of the number of coconuts that Dave eats every day is just the ratio of how many coconuts Bill eats today compared to how many coconuts Bill eats in time 0 times how many coconuts Dave eats at time 0, so just that ratio. And so we're just going to use that to show that Bill consumes a constant share of the total endowment in each period, again with market clearing. So here's just a very basic market clearing condition. We know this holds for all t. But notice that in each period, ETD plus ETB, well, that's just total endowment, or big ET like this. And again, I'm just going to substitute this guy in for CTD. And then I'm going to have something that looks like this messy equation right here. All I'm going to do is I'm going to make that look a little simpler. So here is CTB times this whole fraction right here. And then I'm just going to take that fraction and make it a little easier. So I am going to say that this is going to be C0B over C0B instead of 1. And what I'm going to do is I'm going to take that to the other side. So notice that I have this equation right here. This is what went into this green parentheses. And I'm going to move that to the other side. So I'm going to get that Bill's number of coconuts that he eats in time t is equal to this ratio right here times ET. Well, notice that these are all zeros, so these don't change with time. So this is a constant ratio because we know that C0 is just a given number. And I'm going to call that given number theta. And notice that now I've showed that the number of coconuts that Bill eats in time t is exactly equal to that constant ratio theta times total endowment in each period. And now I've shown that the number of coconuts that Bill eats in each period t is just a constant fraction of the endowment, which means, of course, that the number of coconuts that Dave eats is just going to be equal to 1 minus theta times ET. So Dave is also consuming a constant fraction of the endowment. It's the fraction of the endowment that Bill is not eating. And again, both people are then consuming a constant share of the endowment. So if I wanted to find that, I could do the same thing we've done before, where we use the budget constraint. And so notice that I've just written out this budget constraint. In each period, Dave is getting 1 coconut, so his little ET is 1. So I'm going to start with Dave because I know that whatever coconuts Dave doesn't eat, Bill is going to eat. So if I can find whatever Dave's number of coconuts that he eats in a given period is, I can just take the total endowment, subtract that, and I'll get how many coconuts Bill eats today. So I'm just going to flip this. Notice that CT is now theta ET because it's a constant share of the endowment. And so ET is flipping between 3 and 1. So I'm just going to write out this sum a little bit and collect it into 2 summations. So the part in pink is going to be beta to the 2t times 3. The part in green is just beta to the t, and then I pulled out the theta. This is beta to the t times 1 because we said pt is beta to the t and little et is 1. So that's 1 over 1 minus beta. And then I'm just doing my fun summations to get this part in parentheses right here. Then I'm just doing some algebra to go ahead and get that to be a little more clean. And I'm going to get that theta is 1 plus beta over 4 plus beta if I did my math correctly. If you're looking at this and you think I did not do my math correctly, please give me a comment so I can correct that. Do my best, but I can only do so much in the world of math. But intuitively, this should make a lot of sense because if I'm perfectly consumption smoothing, even if my endowment is changing, it should be the case that I sort of try to smooth based on that endowment. so I should eat a constant share of the endowment rather than a constant number of coconuts. Now I did this for certainty, but notice that if I go way back here, if this was uncertain, the only thing that's really going to change is this CT is now going to be like a CT of S to the T, and this ET is going to be a function of S to the T. But what's going to happen in the math is not really that different. And the reason it's not that different is if I have uncertainty in here, right, this is going to be like the probability of ST over the probability of some, say, 0 that we pick. And that's going to go right into here as well. But those probabilities are going to cancel out, and we're going to be left with the same thing. We're just going to have a bunch of CTIs of ST, where you see CIs and CJs. So nothing fundamental about the math is going to change. You're just going to have a bunch of extra STs hanging out. But you're still going to get that what's going to happen is you're going to get that CTB of ST is just going to be equal to theta, and this ET is just also going to be a function of ST. So that's the only difference between certainty and uncertainty. So I think it's a lot cleaner just to talk about it with certainty rather than uncertainty. But again, if it would be helpful to sort of write out the full math in the uncertain world, please let me know in the comments. And again, if this video is helpful, if it makes a lot of sense, also put that in the comments as well. And if you're finding these videos helpful and you haven't already, please like and subscribe. And hopefully we'll see you next time for another case of econ struggles.